All right, this is Mr. Ainsworth, and we're going to get to a homework problem here, number 2, dealing with a population growth problem, dealing with rabbits here. Now, because it's a growth issue, we're going to have to recall the exponential growth function here. But let's first read the problem here. In 1995, there were 85 rabbits in Central Park. That's in New York, or back east. All right, the population increased. Okay, it went up. Okay, by 12%. So instead of the next year being only 85 rabbits, it was 85 rabbits plus 12%, or 112% of what it was the previous year. Question is, right here, how many rabbits are in 2005? Ooh, that's how many years later? Oh, it's probably 10 years later. Okay, so what we want to do is figure this just by taking a look at what 12% is all about. We know that 12% as a fraction, it means 12 per 100. Now when you divide 12 by 100, you get 0.12. And if you don't believe me, or if you don't remember your basics from 3rd grade, don't worry about it. 12 divided by 100, all right, is 0.12. 12 hundredths, that's how you say that decimal, 12 one-hundredths. Tenths, hundredths, 12 one-hundredths. All right, so that should make sense. All right, now, this is what they start in the year 1995. All right, so let's record that. In 1995, that's year 0, that's the start. All right, there are 85 rabbits. That wasn't in the table, so I want to put that in there. All right, after the first year, it went up. Oh my gosh, it's increasing. How much? Well, by 12%. All right, so what you need to do is figure out what is 12% in addition to 85. Well, we know that 100% plus 12% is equal to 112%. Ooh, that's really tough. All right, so what's happening here is that after the first year, you don't just have 85 rabbits, you have 112% of that, which means you have to multiply 85 times 100%, 112% to figure out your new value. Now I already put the value in there in 85, and we'll show you how to get it. All right, but let's do the obvious here. 112% is 112 hundredths. All right, divide and move the decimal place 2 places to the left. If you want to use your calculator, and if you can't do that in your head, no big deal. Divide, all right, and you get 1.12. Pretty obvious, 1.12. So you change it to a decimal first. Now, what we want to do is multiply by 1.12, or 112%, to get to the number of rabbits for the following year, which is 1996. That's easy to do with technology, guys. All right, so what I want to do is start off with 85. Okay, that's how many rabbits we start off with. Multiply it by 1.12, which is 112%. Holy cow, it's 95.2, but you can't have a fraction of a rabbit. That's impossible. I've never, well, unless he's been eaten by a coyote, but this one hasn't. All right, so that's why the directions say, right here, ooh, round to the nearest rabbit. Why? Because you can't have fractional rabbits unless they're dead and half eaten or partially eaten. All right, 0.2 is 1/5 of a rabbit, but you know, these rabbits aren't eaten, okay? They're live. Okay, so we have 95 rabbits. Okay, that's what it says. Now, what do we have to do? We have to multiply by 112% again. How about that? Well, with the calculator, it's a piece of cake. You just go times 1.12, and you get 106.6, and you're going to round that up. All right, going to round that up to about 107. So let's do that, 107. So it's 107 rabbits here approximately, all right, times by another 112% to figure out how many rabbits you have the following year. 4/10 is lower than 5, you round down to 119. So you have about 119 rabbits here. Again, all you do is multiply by 1.12 every single time. You do this again and again, and you get to year 2005, and you can figure that out. And then afterwards, I'll explain, you know, how a smart mathematician would do it, because what would happen if you want to do it in the year 2055? You don't want to keep on doing this, you know, over and over again 50 more times. All right, that's tedious, it's boring, and there's a lot faster way to do it. However, we're going to do it by hand first, and then I'll show you the quick and easy way to get the how many rabbits are in year 2005 or after the 10th year. All right, because 10 years have passed since 1995 to 2005. Just do the math. Okay, so what we have let's get back to the calculator here. We got 119 roughly times 1.12. All right, hit enter. You got 133.7, which rounds to 134. So we have 134 rabbits here. What's cool about the calculator, or this TI-84, is that if you do it 2 or 3 times, and then it remembers the pattern of what you're doing here, which is multiplying by 112% or 1.12, and then it does it for you. So if you just hit the enter button right here again and again and again, it will repeat the pattern and give you the next value, which is 149.7 or 150. So there's 150 rabbits in year 2000 after the 5th year. All right, do it a couple more times. So what we have, let me just do another time here, one more. There we go, you get 167.7 or, and let me just capture this. Let me just show you here. Give me a second here. Let me capture my screen so I can record these values easily. There we go. All right, you gotta love technology, man, because this is cool. All right, paste it back in, and there we go. All right, now I have my values. I can just bring them into the table. So 150 was here. This is 168. 168. Again, you're going to round up there. 188 rabbits here in 2002. And then we have here 210 rabbits. And then here we got to round up again. 236 rabbits in 2004, and 264 rabbits in 2005. All right, and again, all you keep on doing is multiply by times 1.12, which is 112% every single time. So times 1.12 times 1.12 times 1.12, or 112%. Okay, that's how you do it by hand if you didn't know your functions. However, the general growth function looks like this: y equals a times 1 plus r. It's a growth function, so you add raised to the x power, where this is the initial amount, amt is amount, and then what is this r? Well, that's the growth rate. The growth rate as a decimal, in this case it's 12% or equal to 0.12. The initial amount, well, that's this right here. That's the initial amount, and that's your A. A is equal to 85, so I'm going to put 85 here in a minute here and get my function. So what do I have here is y is equal to 85, my initial amount, times 1 plus the growth rate as 12% is 0.12 raised to the power of x. All right, what is that? Y is equal to 85 times 1.12 to the power of x. That's my function. Now, if I want to figure out how many rabbits there are in 2005, I can use this function. So let me show you. If I enter it in, let's enter this in. Let's clear this previous one out. I'm going to enter in 85 times the quantity 1.12 raised to the x power. I got my function there. I'm going to go zoom. Let's see. Let's go down here. Zoom stat number 9. Okay, and that doesn't show me that well. The window needs to be much higher than that. So y max is not big enough. It's only 100. So let's make it 300 so I can see what's going on here. Oop, let me clear that out. So now I can see my function right here. This is the growth curve here. I'm going to hit trace. I'm going to enter a value in of 10. Okay, there we go, 263.9, which rounds to 264. So I can use the graph in trace mode to figure it out. All right, here, let me capture that and show you guys. I always like to show you how to use the technology, and so you can learn it here. All right, there we go. So we have the same value here when x is 10, y, or the number of, when x is 10 right here, y is equal to 264. This is rounded to the nearest rabbit. This is rabbits right here. Okay? And this is after the 10th year, after 10 years, which is pretty cool. And then, but you can also do another way too. Here's another way. Go second, quit, and quit out and clear out. You can use your function. So let's take 85, raise it to the power of 1.12 to the 10th power. Why? Because we want to figure out how many rabbits there are after 10 years. Holy cow, we get the same value because it's the same function, guys. 264 rabbits after the 10th year. If we want it after the 20th year, no big deal. You take 85, raise it to the power of 1.12, and take it to the 20th year, which would obviously be 10 years later in 2015, and there's 820 rabbits, okay? So what's cool is that you could use the function that you create to generate all your values. You don't have to do it step by step every single time. No, there's a faster way of doing it. All right, so remember the calculator techniques because you can use them to your advantage. Oops, hang on for a second. Give me a second here. All right, so just going to paste this in. There we go, right there. All right, so I did it two different ways. I used the graph in trace mode in my first picture here. Remember, trace mode is your friend right here. Use trace mode. All right, and enter any value you want. Any value, in this case year, you want. And then you can do it, use your function here. This way is using your function right here. And after that, it's easy. And then if you wanted to plot your graph, you put your years down here, years after 2000, let me see, not 2000, I'm sorry, after 1995. So this is the number of years after 1995. So years after 1995. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then you can you're going to have to change the scale here because we've got to go all the way up to 300 here. So I suggest you change the scale. Change scale because the Y max is 300. And so that's no big deal. So 50, 100. If we go by 50, this is 100. Let me see, 25, 50, 75, 100. I bet we better do by 50s. So 150, 200, 250, 300. Now we can graph. All right. So if we graph all these points right here, let me zoom out. All right, so I can see all my points. 0, 85. Roughly here, it's an intercept right here. 1, 95. A little bit higher. 2, 107, so a little higher. 3, 119, a little bit higher. 4, 134, a little bit higher. 5, 150, a little bit higher. 6, 168, a little bit higher, right? 7, 188, 7, 188, a little bit higher than that. 8, 210, a little bit higher than 200. 9, 236, right about there. And 10, 264, right about there. So there's my growth curve. Let me do this a little bit better here. Guess what? It looks the same. Okay, there it is, the same function. There it is, and there it is right here. Okay, same thing on the calculator as we do on paper here, guys. All right. So that's, I know it's a video and I probably went a little bit too fast, but guess what? It's a video. It's pause and play, rewind it, listen to it a couple times, try it on your own, and get good. All right, and this is Mr. Ainsworth, and I'll see you in the next homework problem.